Okay, this is a new thing, new and shiny. Whenever I do a presentation from now on, I'm going to do a small screencast using the same deck, just so I can remember all the wonderful jokes and relive the experience. And of course, it might even be useful to somebody else as well. So this is basically a short overview of what LoRa is, why it's a good idea, and what's happening in Hull with LoRa. Tell Lora I love her, all the other jokes that make sense at this point. It's not responding. Ah, we go, you see. It does work eventually, Rob. Have faith. My name is Rob Miles. I taught computer science at the University of Hull for a very long time, in charge of twisting minds and crushing dreams. Yeah, I was quite good at both those. I'm a Microsoft MVP. I blog at robmiles.com. I tweet at robmiles, and I write the odd book. Here's a few odd books. This is the C# book that I wrote with Microsoft Press. One customer review of 5 stars. Thanks so much, Mum. You're awesome. I also did a book on Python as well. There you go. 6 reviews on this one. Not quite so good because the extended family seems a little bit less impressed with it, but you can rush off and buy those. And if you want to buy Sunday 6th of May, get in quick. You'll be fine. I've also done a thing called the C# Yellow book, which is a book about C#, which is yellow. You can download that for free from my home page, and you can also buy it in Kindle and also on paper format. That's the promotional stuff out of the way. Let's get on with what's going to happen in the presentation. What is LoRa? A bit about LoRa and MQTT, building LoRa devices, and a final bit about the Connected Humber endeavor and air quality and what we're doing about those two things. Awesome source. LoRa, clues in the name. Low-powered radio, long range. So the idea of LoRa is that you can send signals a long way using a couple of tiny batteries. The idea is that this is kind of like a way of it's a breaking change in terms of the way we do stuff. Breaking is the wrong word. It's a new thing. It's a new paradigm. It means you can send small amounts of data a very long way at extremely low cost, which is rather nice. It was invented really for use in battery-powered devices with a very long battery life kind of thing. Sensors you're going to bury in the road or stick under bridges or out there in fields or whatever. The transmitters themselves are very easy and cheap to add to a device to make it LoRa-enabled. It uses a thing called spread spectrum. That sounds to me a bit like butter, but I'm sure it isn't. They send the messages in some kind of cunning way. In terms of what you get as a person wanting to use LoRa as a technology, think of it as a form of SMS message. You can send a small text message to somebody else. It's like a phone call. You can't stream media or do big things, but what you can do is send small, simple status or sensor readings or whatnot from your remote device into your cloud backend, whatever you like. The range is, they say up to 15-20 kilometers, although that depends on conditions. In urban, where you've got buildings and whatnot in the way, about 1.5 to 2 kilometers works kind of well. In the open fields, yes, you can get it to go a very long way. It uses different wavebands around the world. The one I'm interested in is the 868 megahertz for Europe. That's the one which we use, what with being in, well, sort of. That's a depressing subject, Rob. Don't go there. We are in Europe. I'm from England. We're in Europe. We use 868, 915 for North America, and 433 for Asia. The ASEAN 433 band, you can actually use that in the UK because that's an area which is kind of unlicensed, where you put things like car remote controls and stuff. But if you buy a 433 megahertz device, like I did by mistake, you'll find it'll work point to point, but you can't talk to any of the LoRa WAN devices that you can get access to, which is a bit of a stumper. So don't do that. Go for the 868. No need for a license. It's the unlicensed band, but think in terms, if you're going for a commercial product, of looking at making sure that your devices are properly certified. And the way to do that is to buy a device that contains a built-in LoRa radio that has been certified. So do some thinking about that. I'm looking at this from a hobbyist perspective at the moment, so I'm buying things from China and using those, and they seem to work fine. If I was making a product based on what I'm doing, I'd actually think in terms of sourcing some properly made and certified components I can then sell with confidence that they'll not get their users into trouble. So yeah, that's a thing worth bearing in mind. The idea is it uses this adaptive data range technology, which means that if it detects that the thing it's tending to is a bit closer, it'll use lower power and send more data. It's interesting that if you're used to things like Wi-Fi, when things happen pretty much instantly, when you start using LoRa, the bit rates, the data is sent quite slowly, so things can take the order of seconds to travel. That's not a problem, as we'll see in a minute or two, in terms of the applications that I think LoRa is great for. Data centers a packet. The packet goes from 50 to so the packets are quite small. The data you send will not be enormous, and you're not supposed to use the network for more than about 1% of the time. So you shouldn't, in any given minute, you shouldn't transmit for more than a second or so. But again, in terms of how this works and what you're going to use it for, I reckon this is fine too, but it's worth bearing these things in mind before you pitch a video conferencing system powered by the LoRa network, which would end extremely badly. So here we go. It's if you just buy two LoRa devices, you can make them talk to each other. If you want to monitor the temperature of your prized marrow in your greenhouse, a few hundred yards away from your main house, then LoRa will be good for that. You could buy a couple of LoRa devices and use them as an intercom. You could push temperature readings in one end, and your LoRa receiver in the house will pick those up. It's kind of like a broadcast thing, though, which means that anybody else listening in would see those messages on the same frequency, and they could eavesdrop on your marrow temperature, which sounds really worrying, but probably isn't. If you want to use LoRa for more complicated things, point-to-point, peer-to-peer type stuff, you'd have to make your own addressing scheme, and if you were concerned about marrow temperatures or whatever being sent out to anybody that wants to listen, you may have to put some encryption on top, but you would have to do that. So if you're doing LoRa peer-to-peer, buy the devices, use the low-level network command to just push data packets backwards and forwards, and it works a treat. So if all you want to do is make a few sensors around the place talk to a central station, LoRa is good for that, and it will work quite well. And like I said, low power, long range. If your allotment's a mile or so away, it might well still work. So that's all quite good. But what I'm keen on is LoRa WAN, the LoRa Wide Area Network. In this, we put our LoRa receiver transmitter into a device which we call an endpoint, and that becomes part of a particular LoRa application. And within that application, each LoRa device has a unique address. For some reason, I can't quite figure out where it came from. I was thinking at this point about cow tracking. If I have a whole bunch of cows in a field, or maybe I have two fields, maybe I'm number one in my field, maybe that's not funny. Moving on. If you're making a cow tracker to know where your cows are, you could whack a GPS-enabled battery-powered device on the back of each cow, and that would be an endpoint in your farm cow tracker application. If Farmer Joe next door has cows as well, he'd have Farmer Joe's app, and his sensors would talk to his LoRaWAN application as well. The idea is that the cow tracker will push a message up every now and then into the ether, and a LoRa gateway, a device which receives LoRa messages, will take that and forward it onto a larger network to a LoRa server. And then if you do this, you end up with a thing called a LoRaWAN application. So yeah, let's talk cow tracking. That's the thing I thought I would never say, but I'm saying it right now, so good. We fit our cows with devices, and there's I don't take that many pictures of cows, surprisingly. But here's the same one. I've got two cows in my field, and they've both got these trackers, and every now and then the tracker pushes a message to the LoRa gateway. The gateway takes those messages, and it constructs a packet which is sent to the LoRa server. The packet contains information like signal strength and whatnot, along with the gateway location, and each gateway has a unique ID on the LoRa WAN network, so we know which gateway received it. The server gets the message. It then constructs a packet which is passed on over another network connection to your back-end server. Now, at this point, you can do what you like, because that message will appear in your server perhaps as an MQTT message, perhaps as a web request, perhaps the LoRa server saves the data in a database which you then pull information out of later. But when you get into the orange stuff down here, this stuff here, it's entirely down to you what you do with the data. At that point, it's your application. You can do what you like. If I have several gateways, because I have several fields and lots of cows, it's quite possible that a single message from one cow will get picked up by two gateways. That's absolutely fine. The gateways both send their messages to the server. The server will then construct a message that's sent to the back end, which contains details of all the gateways that receive the message. So if two gateways receive the thing, I'm going too quickly here. If two gateways receive the messages, then what happens is that we get a message saying, here's your packet. It was received by these gateways at this time. These gateways have particular locations, so you could do some primitive triangulation to try and figure out, based on signal strength and gateway location, where your cows actually are from their signals. But I'm not convinced that will be usable for a proper cow tracker. I think my cows will still have to have GPS. But the fundamental principle is the thing we're talking about here, in that what happens is that if several gateways get the message, each one of them will send a packet to the server, which aggregates these, makes a single message containing all their data, and pushes it to the back end. Bear in mind also that gateways, they are key to a particular sort of LoRa installation, and they will take messages from applications that are out there doing stuff. So Farmer Joe can use my gateways to talk to his cow tracker application running next door. But the gateways will ignore packets that aren't part of their installation. So we'll talk about that a bit more in a few minutes. But it all actually works quite nicely. But if you think in terms of cow tracking at the moment, then you're coming along quite well. So this gateway, what is it? Right, it has a LoRa radio receiver in it and a network connection. It receives the endpoint messages from my cows, and it pushes them onto a LoRa server. You can, if you want, get a really cheap LoRa device. A node can be reprogrammed to act as a primitive gateway, but they don't expose the full behaviors of LoRa because they only speak to one particular LoRa channel, whereas a gateway will have 8 channels on which it listens simultaneously. And for some of the more advanced LoRa features, you do need that. The cheapest proper LoRa gateway is about 120 quid plus the cost of the Pi to run on it. So about £200 will get you in the game gateway-wise. If you're lucky, someone living nearby will have a gateway you can use. And some places, and in Hull we're very keen on this, we're going to try and get some gateways right across the city and the surrounding area. So as far as you're concerned, the gateways will be there at the time you turn up with your LoRa device. I really hope that's the case. We're talking about putting a gateway on top of the Humber Bridge, which is a very, very high bridge and will get very good coverage and might be fun, but I'm not going up there to install it because not that big on heights. But moving on, so we have this idea of what a gateway is, and this is a simple, cheap one that you can buy from Dragino. It's single channel, which means it's limited, but it's okay for playing around at home. And you can pick these up for about £50 or £60 on Tindy or AliExpress. I've got one, and it's fine, but a little bit limited ultimately. What tends to happen is that you get 1 in 8 packets because the LoRa node will cycle around the 8 different channels. So this thing listens on one channel, it gets every 8th packet, which is kind of interesting and sort of workable, but not really. So we'll move on and get a proper one. But at this point, I must also mention this wonderful thing called the Things Network. Now, this is one of these things where the community is doing great stuff. The Things Network's been going for a while, and they're basically building a global Internet of Things network together, as it says on the web page, on the tin. They've actually got a network of back-end servers linked to a worldwide network of gateways, and the idea is that if you want to put an application for tracking your cows or whatever you like onto the Things Network, you sign up. You build your application, you get some unique keys that you can place in your nodes and whatnot, then away you go. If you buy yourself a gateway, you can plug it into the Things Network and extend their reach even further, which is just astonishing. They are very, very keen on just rolling this stuff out. They provide a service which, as a community, you can use, and it all just works. I'm on the Things Network, all my stuff's on there, and we're passing packets around, and it's all jolly good. If you want to, you can extend the network reach by putting your own gateway on the Things Network. That's a nice thing to do. And if you do that, the Things Network will sort of say thank you very much. You appear on their map, and I know folks that have done that. It's a nice thing to do. So here we go. This is Hull. This is Hull as of around yesterday, and we can see that in the middle of Hull we've got some gateways, and up towards the Cottingham area where I like to go, there's gateways up there too. There's not that many, but we do get reasonable service around most of the area. We want to see even more. Because the more gateways you have, the better coverage you've got. And it is the case that local companies, local telecoms companies, Connexon and KC Communications, are actually installing gateways for commercial use as well. The way I see this going is that you would get your application and your endpoints and your whatnot proved using the open community-based stuff, and then you might decide to get real and sell a product based on what you've done, at which point you talk to people like Connexon or KC and you get quality of service guarantees and you get all that kind of good stuff that you can then sell on to your customers. But as a starting point, we're doing pretty well. We have an aim to get even more gateways across the city, and we're working on that, which is, that's coming along quite nicely, which is rather pleasing. The server back end, we don't really care about that from the Things Network point of view. We just use their servers. That works nicely. You can actually get your own open source copy of the Things Network code and run it and make your own local proprietary network. That's absolutely fine. So there are all kinds of nice things you can do. But just to get started, you use the free ones. That's what I do, and it works an absolute treat. Now, there are issues to do with security. As I said when we talked about peer-to-peer, anybody can listen to any given LoRa message. The way that we get security in the LoRa application space is that each endpoint has an application which is identified in the messages that it sends, and each application has an encryption key which can be baked into a device or deployed via the LoRa network. So the idea is that they will then encrypt the stuff before they send it, and then the receiver will decrypt it. It's based on AES 128.802.15.4 security, which is reasonable. You don't send huge amounts of data using LoRa, so someone looking to break your code won't have a lot of data to work with. I wouldn't. Would I put my pin out over a LoRa network? Probably not, but I wouldn't pass it over an unencrypted Wi-Fi connection either. So, be mindful of that a little bit, but it is secure. There is security baked in, which is nice to know. There's no such thing as default passwords. When you create a device, you tell the device which application it's part of. Is it my cow tracker or Farmer Joe next door's cow tracker? And at that point, it is entitled to application. There's two ways in which the device can then activate when it connects. The first one's called activation by personalization, which means that you burn credentials into the endpoint before you deploy it. The second way is called over-the-air activation. This is a bit easier. If you've got a couple of devices, do the personalization thing. It works a treat. I've done it many times. It's absolutely fine. If I had 1,000 devices to do, that'd be a bit harder work. So that one I would use the OTAA, because the keys are actually produced during the conversation, and you can just bung a whole bunch of devices out there, and in that respect it's a lot easier to manage and deploy. Keep you pays your money, you takes your choice. But the other thing I would mention is that for OTAA, for this guy to work, you have to have a gateway that supports 8 channels. Now, if you have a single channel gateway, a little cheap one that you've put together, or you're using the very cheap Regino one, you're doing this chap, ABP, because that's anyone that works in that context. So keep that in mind and you'll be fine. This is what a device looks like when it's on the actual design page in the LoRa Things Network website. Get your brain to work, Rob. Okay, so you actually give the device a number, which I made my device number 1 because I have no originality. When I made my application, which is called Rob's First LoRa Application, I actually got given by the Things Network an application end user identifier, EUI, I think that's right. And that was made for me and used to construct the device address, and then these two values, network session and app session keys. Now those I will drop into my Arduino application on my device that's talking to the network, and they will actually then be used to sort of sign any messages that endpoint will send. Now there are actually addresses burned into the LoRa chips as well to make them identifiable at the radio level, but we don't care about that. This is stuff that we make, and you can see there are buttons here that I can press on the web page to copy the session keys into the clipboard, so I can then paste them into my program. In fact, this is my attempt at security. These are those keys pasted into the Arduino C program that will then go off and do my thing. So I think you should find that number there will match. Let's go on. Let's have a look. Yeah, there we go. 260117A2. That's my device address. Go in here. That's the same thing actually coded into the variables inside my program. And this works. If you have 10 devices you want to deploy, just do this. It works a treat. It's lovely. There are my applications. There's Rob's first. I've made a few more as well. In terms of managing, you can actually, several people can sign up and share applications they work on together. So you're not tied to one particular login being responsible for looking after a given app. You can actually spread these things around. And again, these are the EUIs for the different applications. The things network ones tend to start 7, 8, blah, 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 or is it 7, 0? I can't quite read that. And so that's how we manage the fact that things network apps, connection network apps, KC network apps can all coexist in the same ether and not get confused in terms of messages being passed to the right place. So if a things network gateway sees a packet coming in, it doesn't start with 7, 0, 8, 3, whatever that is, then it'll just ignore it. It'll say, it's not for me, I don't care, it'll ignore that one, and life will go on. If it finds one with this number, it'll pass it to C40i Robin. If it finds one with C40i SensorNet, it'll go there, the number there, it'll go there. So these things are a bit like phone numbers, or if you like, MAC addresses, I guess, that tell you which application they're part of. The endpoints, yeah, here we go. This is effectively got 2 devices attached to it, and the endpoint is only ever linked with one app. So yeah, my cow trackers talk to my cow tracker app, nothing else. If I have a milk management app as well with different sensors, that's fine. They'll talk to the other app and they'll deliver different data to it, I would think, as well. So those are my devices, and yeah, you can add more if you want. Click register device, give it the number you want it to have from your perspective and the name, and then you'll get back the keys you can then drop into your application. This is my first ever LoRa application in action. It sends the message, hello world with added cheese. If you don't believe me, look at the end. There's EESE and hello world. There's the E in hello world. And it does it quite regularly, which is mildly embarrassing. I didn't run it for very long. I was so pleased it worked. And these are basic lumps of binary data. A message over LoRa will be a lump of binary. In real life, that's how they are anyway. But as far as we're concerned, it's just a lump of binary data. Each particular message has a given counter number, which is incremented as they are sent. And the idea here is that a station will record the highest number it's got to and then continue on with that going forward, so that we don't have any repeat packet numbers and stuff, but that's for another day. In terms of how it works, though, there's hello world with added cheese, which is such a message. And in terms of what you see, this is the full payload of that message. There's the payload in terms of the message. This is a chunk of JSON which gives you more information about that message itself. This is metadata, if you like. And this tells you the time it was received, the frequency, the modulation, the data rate, the coding rate. And then there's a bunch of information about the various gateways that picked it up. In my case, only one gateway picked it up, the one that's actually on my desk at the moment being used for single channel. And so that has a gateway ID on the Things network. And there's a timestamp when it was received, the channel. These 2 guys here give me a feel for signal strength, which is how you probably think about using it to figure out where things are based on the signal they're sending. And then these 2 guys are latitude, longitude, and altitude, which you can actually put in, or you can. Some gateways have got GPS built in, so they'll actually tell that when you plonk it down, it'll figure out where it is and then send that back. But the idea is that, important point to bear in mind, if 5 gateways receive this payload, there'd be 5 of these in the JSON, and then my back-end software could make sense of those. So when I start picking up information and pulling it into my application, what I'll find is that the back-end server will actually give me all this stuff, which I can then use how I like. It's all there for my application to use. This is how I send stuff. This is a library called LMIC, which is a free download for Arduino devices. I'm keeping the focus on Arduino because that's kind of how I like to travel in terms of making small devices. The important statement is this guy here. I'm pointing at it with my fingers. Ha! That's not working. This guy here, which is being given a block of data starting at my data, that's the size of it, and that statement there will actually push the message up into the LoRa infrastructure. It might not be received, it might not go anywhere. I have to wait for an app to come back before I know, but that's how it works. To get my sensor information, this is our air quality sensor, which is giving me temperature, pressure, and humidity, along with the parts per million particles per cubic meter. I apologize. 2.5 micron and 10 micron diameter. I have my 5 bytes of data, and I actually go through a bit of mathematical jiggery-pokery to take the numbers, reduce the range, and reduce the precision to values that kind of make sense in the context we're using them, and squeeze all those those readings, all those 5 readings, into 5 bytes. So this is actually how I go about making sure that my little data packet that goes over the LoRa network is as small as possible. I don't send the things in decimal, I don't send the things in text, I send them as binary values that I squeeze into 5 bytes on the way out. And then at the back end inside the things network, I take that block of data, here they are, here come the bytes, and I reverse the process. So these guys get shifted and multiplied to make numbers that make sense. I make a packet called, there you go, a tuple, yeah, that's a good word, which has got all those fields in it, and I bung that thing out, and that's my answer. And then my application can then kick in and start doing things with these numbers going forward. So at that point, LoRa has passed the data into my application, and I'm away doing things with them. At this point, you can think in terms of making use of that data by means of what the Things Network calls integrations. Now, some of these are provided by the Things Network, some are provided by third parties. If this then that, you can make things respond to messages from your LoRa devices and trigger actions, and if this then that, you've got a thing called Keying. Keying is a great one. They provide lots of tools for compressing and displaying. You can make dashboards using Keying very nicely, works very well. Data storage is the one that I'm going to be showing you in a minute or two. That will store stuff for up to 7 days on the Things Network servers, and then you've got HTTP integration here, so you can actually make it generate a web post or a GET or whatever you like to produce information, and you can also do MQTT integration, of which a little bit more later. So this is just a picture of the things. You just click on one of these, add it to your application, and then the data is taken from the LoRa device and passed into whichever one of these backends you're keen on. I'm using this chap, and the idea is that it'll store it up to 7 days, and you can then get your readings back by various different means. Hit go to platform, it takes you to a page which allows you to use a tool to actually generate web requests and pull the information back. And it's called Swagger. It's really, really nice. It's worth playing with. You just basically have a bunch of RESTful calls, and I wrote some Python which pulls things back as well. So that's all jolly good, and that's where your LoRa side of things kind of becomes the infrastructure, and you begin to build your app, which is then going to have whatever front-end display and behaviors that your customer or you yourself actually want. Now, bear in mind that everything I've told you up to now is how to get data from an endpoint, from your cow, telling you where the cow is. You might want to tell your cow things as well. That's absolutely fine, but it's not quite as simple as just sending a message to the cow, because your LoRa endpoint, saving battery, is not listening all the time. There's 3 different classes in terms of how reliable and useful you want your downlink message, or message from the server back to the endpoint, to be. Class A, the way it works is that whenever the cow sends its location, the LoRa endpoint will listen for a few seconds for a message from the server at that point. So if my server wants to tell the cow something, it has to wait until the cow checks in and then push the message back. So if the cow never checks in, we never get to talk to the cow, which would be sad, but there you go. Class B, bit heavier on the battery now. What happens now is the endpoint will listen at regular intervals. It will check in, it'll sit there and listen, and you can then transmit at those times, and the sensor will pick those up. And Class C is the battery draining high power one, where the thing listens nearly all the time, but your battery goes flat quite quickly. The way I see it, the ability to pass information back to the endpoint is something which you really shouldn't hang your application on I like that it's okay, but I like to think in terms of LoRa as a way of reporting data in, not actually getting commands back again. There is talk on the internet and demonstrations of people doing things like firmware update over LoRa, which can be done, but I wouldn't like to make it part of your standard MO for your app, because I think that the data rate and the connectivity side of things means that it's going to work against you a bit. I'd love for that to change, and maybe future versions of LoRa will get very good at it. But for now, I think of LoRa as a way of my cows telling me where they are, but me not really telling my cows much. If you see what I mean. That makes sense to Robert anyway. This is what happens in your code. When you get an event from the LMIC drivers, they get fired up as a call into a method which deals with the event. That contains a big switch statement, and the case TX complete is I have sent your message, I have listened for anything incoming, and if the data length property of the LMIC service is not 0, I've got some data for you. So what my code here does is it basically takes the data out of the receive buffer, this thing here, puts it into another buffer so that I can be sure it's not going to get fiddled with. Then I can effectively pass that to my method called actOnJSON command, which takes the buffer and acts on it. Now, the JSON commands I'm using are absolutely tiny, but they are free text. So I'm not particularly using the LoRa network very nicely here. But like I said, I don't see this being used very much. But this is how you can do it if you want to do it. I'd love someone to prove me wrong on this and actually have a LoRa thing that works two-way reliably. So if you've got one of those, please tell me. I'd love to see it. And so that's all good. Yeah, like I said, you're not guaranteed. The message from the server is not guaranteed to get through. I've discovered on my playing with the network that getting messages from the node to the server tends to work quite well. But I've been in situations where I can pass them one way, but replies from the server back down don't seem to get through. This may be an aerial thing. I don't know much about that side of things, but keep that in mind. The sending process will only know if it's actually been received by the node if it gets an ACK back. And so think in terms of application design and how you would actually work with that limitation, because it is a thing worth bearing in mind. So, LoRa on a page. Cheap endpoint devices, £5 a pop. Low power, long range, lovely. LoRa, you see. Great for small packets of data, not great for streaming video. You have the gateways that provide the, in the name, the gateway onto the network. You need servers to manage those. And the Things network will do all this for free, but you can actually buy into other people's services as well. The endpoint is tied to a particular given application, protected by encryption at the application and the network level, so you can be fairly sure that people aren't listening into your LoRa messages and doing things with them, which is all jolly good. So I'm going to mention LoRa in terms of MQTT and deployability now. This is kind of funky. Message queue telemetry, it's a thing worth getting into if you're not into it already. If you're into IoT and you want to make things connected, MQTT is lovely. It's you have these things called brokers, and a broker is a process running on a machine that will accept, it'll subscribe to messages and pull them in, and then you can effectively you can connect to the. I'm explaining this really badly, so I'll step back a little bit and start again. The broker sits there, and as a client of the broker, I can do one of two things. I can push things into the broker to say, here, have this piece of data, and I can subscribe to messages that other people have actually sent. Think of the broker as someone managing a fan club for a pop star. Do we still have pop stars? I think we do. So what happens is that the broker's in the middle. The pop star will say to the broker, hey, I've just made a new record. And the broker will then push that out to anybody who has subscribed. So you've got this idea that the fan club manager has got a whole bunch of people subscribing to messages from the pop star, and he's listening for messages from the pop star to say, I've made a new record. Do people still make records? I have no idea. So as an interested person from a LoRa perspective, from an MQTT perspective, if I want to get temperature and air pressure from a sensor in Hull, say, I know the location of that sensor in terms of what it is publishing on the server or on the broker, so I subscribe to that, and whenever a new value comes in from that sensor, I get an event firing on my end to say, got a new value, you can deal with this. So yeah, think of it in terms of a fan club manager, but for data. And it's really good. It's quite low weight. You can make very sort of nice little sensors based on Arduino kind of technology, and the servers run on Raspberry Pis, and it's all rather funky. The idea is, I subscribe. The Things Network, hang on, go back again, Robert. The Things Network, bottom bullet point, very important, will pass LoRa onto MQTT. So my network looks like this. I have the LoRa gateway, taking my cow tracking stuff, a network server, network connection, a broker, which is the bit that's taking in messages, and a device. So, for example, if I want a red warning light to come on when this cow wanders out of top field, then that's fine. I'll just have my red warning light device here subscribe to messages from the broker, and the broker will then send a message saying, go red because the cow has wandered out of the field. That's how you would do it. And the nice thing is that if you have other MQTT devices which aren't using LoRa, then just attach them to the broker as well, and the client devices will just receive those, and it'll all just work fine and dandy, which is nice. So yeah, in terms of, here's a single page of, oh my goodness, a phone call. I'm going to have to press pause. Oh, it's international. We don't care about them. I'll just press the red button and make it go away. There you go. Please go away. There you go. It's stopped. Go. It's stopped now. Jolly good. Yeah, that's what happens when you record things at home. Someone's going to ring up and tell me they're from Microsoft, and I'm going to ignore them. So here we go. There are... oh no, go away. Now, one of my philosophies is that I do everything in one take. Because if you go back and try and make a thing perfect, then nothing is perfect, okay? Bad news for you, nothing is perfect. So if people ring up or the doorbell goes, a man once delivered some trousers to me while I was doing a podcast, and that actually worked quite well as well. And I got my trousers, which was good. So back to the plot. PubSub client is your go-to place to put the ability to send and receive messages to talk to a broker into an Arduino device. That's what would be in my red light, which goes red when a cow wanders out of top field. A Raspberry Pi makes a very good MQTT broker. Use the Mosquito software, works a treat. The Arduino devices, ESP32s and whatnot, haven't quite got the grunt to run an MQTT broker, but you can get a Pi Zero, that works a treat. There's a free program called Node-RED, which is awesome. You drive it through a browser, and it lets you design message flows and view data and even do things like mapping, and it's awesome, and it's free for most platforms, so look into that. If you're using Python, the Paho MQTT library is a great one to use for making your Python programs talk MQTT. And if you, the Azure, sorry. Yes, the Azure IoT Hub will process and send MQTT. So if you want to live in Microsoft land, the nice thing about the Azure stuff is that it uses HTTPS by default. It uses secure sockets. If you're actually using Node-RED and Mosquito and whatnot, you're probably using unsecure stuff. So you're pushing information up and down on networks that can be eavesdropped on, which is a bit on the nerve-wracking side. Whereas the Azure stuff, they have a whole device provisioning piece, and they have great big keys, and they can do things like have a device lifetime. So your sensor can then work for a year, and then you have to give it a new key, or you can make things time limited, which is wonderful. And Azure functions are quite cute too. You can have just a piece of functional code in the cloud on your Azure server, which fires up when it gets an MQTT message, deals with that, and then goes back to sleep. No need for a server in the cloud, just a function that takes incoming messages will work very well. So these are all good things to look at if you think about MQTT, and LoRa just plugs straight into that. Okay, let's build some LoRa devices. These are the two that I have built. There's the full-fat Wacko Heltec based one there, and the much cheaper light-in-a-box version there, of which more in a moment. But before any of that, let's talk Semtex. Semtech? Semtex is different. Semtex is more explosive. Semtech is the SX1276 provider thereof. This is a chip which is, here you go, on a carrier board. You can buy these for about £5. Then you can hand wire a little antenna, which is the tap on top. It contains everything you need apart from the... you can use a piece of wire. I do that too, and that works quite well. It costs around £5. Any microcontroller, talking SPI, which is pretty much all of them, will talk to this device, and the LMIC driver code will work to this. 868 megahertz for Europe, of course, but if you buy one of those and enjoy soldering these little wires on, then you're now making a LoRa-enabled device, which is lovely. If you want to avoid the soldering hell, you can buy, this is a shield for an Arduino, which has got a GPS receiver here, and the actual Semtech, I'm going to say Semtech every time, Semtech device on the underside of this red thing with the aerial. So this is basically about £15 will get you a device you can plug into an Arduino Uno, and that will actually get you in business sending LoRa messages. This is a thing called the Doug LaRue PCB, which we've used for events, but no one knows. The PCB is down here, and I may have spelled his name wrong. I don't know. I'm worrying now. That's an Arduino Pro Mini on top with the red light on. This guy is the Semtech device which sends the stuff up. This guy here is a BME 280. That's a Bosch temperature, pressure, and humidity sensor, and put in a little plastic box with 3 batteries and a LED that will flash when it receives a message from the server, and that will run for several weeks on one set of batteries, which is quite cute. You can actually improve battery life by doing things like smashing the lead off there and fiddling with the power supply chips on the Arduino to get even more. And you can buy things. There's quite a nice one for about 25 quid, which will run for months, maybe years, on single batteries, which has got very optimized hardware for low power use, which is rather nice. This is, if you're a Python person, and why not, the LoPi from PyCom. That will let you program Python, and it has a LoRa library. You can use some messages from your Python programs. It's about 36 quid, so it's rather expensive, and when you've bought it, the expense continues because you have to then buy a carrier to place this thing in to program it, which is about 15 or so quid, so that's a bit pricey. Robert likes things that are low cost. He likes the device made by Heltec called the ESP32 LoRa, or Wi-Fi LoRa 32. There it is. This guy uses the ESP32, which is a really powerful microcontroller, which has got Bluetooth and Wi-Fi built in, and on the back of this device is the actual Semtech chip, along with a bunch of other stuff. It has this rather funky little OLED screen as well. You can pick these up for 12 quid, which for what you get is awesome, but the quality is a little bit interesting, and soldering them is a right royal pain. Soldering these pin connections underneath here and not burning a hole in that connector for the display, it is an art. This thing you can get quite good at once you. I haven't actually broken one, and I'm not a great soldering type person, but yeah, it is. You have to put the effort in, but it's the basis of what I'm doing because it's just so cheap. On the back of it is also a battery connector, which you can use to plug a lithium-ion battery in, and there's the battery charge management hardware on there as well. So you can make a really small battery-powered rechargeable embedded device very easily using the Heltec device, and for that reason I really rather like it. And so that's the basis of my work at the moment. This device here, you can see, has got the Heltec device in there. That's where you plug the power in. This device here is actually that's a light in a box that has a cheap dust sensor, and it has a WeMOS device, a D1 Mini, and it also has a NeoPixel ring because it looks quite pretty. And these guys are pound shop rechargeable batteries that cost £1 each, which are, for the price, astonishingly good. If you want to go and you can dig out my sensors and the designs and the software, and in a few seconds I'll show you where to do that. But before that, I want to talk about Connected Humber. We are a group of men in sheds that don't have sheds. I have no shed, but we play with tech and do stuff, and we've done robots, we've done all kinds of bits and pieces. Lots of coloured lights are involved with this. We're looking at air quality as a thing to investigate, and there are all kinds of good reasons for doing this. It's a great field for embedded development. Lots of technical challenges around sensor design, power management, and data management. In terms of air quality measurement in the UK, there are people doing it. The council are doing it. They have some sensors. The government is doing this. But the government air quality readings tend to be produced programmatically, in that they'll have simulations and models which they'll run based on traffic pattern analysis and things to figure out what it would be if we measured it. That's fine. we'd like to measure it as well, just to see if the models are okay and to get some feel at a local level at what air quality is like. We're using sensors that can pick up 2.5 micron particles. These are the teeny tiny ones which can get into your blood through your lungs, and so these are the ones that are the most dangerous to health. We're also quite keen on looking at other things like nitrogen oxide and ozone, but the sensors for those are really hard to make at the moment. So we're sticking with air quality in terms of particles, smoke particles and whatnot, and building devices to get that information and do things with them. The reason why we're doing this is because it's turning out that once you've built a sensor and started getting data, the data generates more questions than answers. And this data was not taken by me, it was taken by a friend of mine called Robin, and he has two sensors which he stuck on his fence outside his house, as you would do. And we were trying to discover or decide or convince ourselves that the sensors that we were buying from China, which cost about £15 each, do produce results which are useful and reasonable and sensible. And we have two sensors. This is the first sensor, the second one. And looking at this part of the plot, we might decide that actually these sensors are rubbish because one of them is giving readings that are going up and down and the other is doing zippo nada. Now, Robin went out to investigate this, and after fiddling with the software and looking at the hardware and starting to really worry that we were in a bad situation here, he discovered that a spider had got into the tube leading to his sensor and laid an egg or two and blocked the pipe, which meant that no air coming in, no read. So around here, Robin goes out and takes the spider out of the pipe, and lo and behold, our sensors start to track. But they're still not particularly well aligned. So at this point here, Robin takes the two sensors and puts them both in exactly the same position, rather than being the different sides of the same fence. And at this point, things start to track rather nicely. And at this point, around 7 o'clock at night, things start to climb. Air quality is going down because the particles we're seeing are increasing. The reason for that is that this whole sample trace was taken around the time of a thing called bonfire night, which in the UK means we go outside of an evening, set fire to wood in fields and set off fireworks in celebration of a thing that not many people can remember very well. And this is sort of showing that, yeah, we are getting numbers that make sense, and we're starting to put sensors around Hull now and get information which is causing us to think about where the pollution's coming from, when it's at its worst, and with a bit of luck we can start driving local behaviour and encouraging people to change the way they drive about and do stuff to reduce the amount of bad air quality in the place, which would be lovely. This is my first proper sensor. This guy has, there's my Heltec. This is the breadboard that I built the prototype. This is the air quality sensor. This is the battery backed up real-time clock, and this is the temperature, pressure, and humidity. And this guy here is a GPS sensor, and this guy here is the aerial for the LoRa. That's what it looks like inside the box, much tidier. And I've even got some buttons so you can pick things from menus and stuff. If you want to make one of those, then absolutely good on you. Go for it. I've put all the stuff on GitHub, of which more in a moment. This is my second sensor. This one, the big sensor costs about £30 or so in parts, which is quite high. This guy costs around £10 in parts. This guy has a cheap particle sensor and a processor and a ring of coloured LEDs. It doesn't talk LoRa. It uses MQTT. I wanted to make one to see how cheap I could make something and if it will be useful, and that's my second design, and that will generate values and push them into the cloud, and we can look at them too, which is nice. If you want to build any of these guys, go on github.com, crazyrobmiles/air quality. I've even put the 3D printable files up there so you can make the cases. I'm sorry I'm called Crazy Rob Miles. At the time I did it, I thought it was like a wacky, zany, because Rob Miles had been taken, so I'd go for a wacky, crazy, woohoo type thing, but actually it looks a bit sad, and I'm very sorry about that. But it's there now forever. I'm stuck with it. But if you want the details of how the software works, it's all up there. Then go onto there and you can find the whole shooting match. If you want to make a device which is connected but not a sensor which is air quality, that's fine. You might find my code and how it works useful to you as well. If you're in the Hull area or want to make trips to the Hull area on a regular basis, then Connected Humber is a great place to go. We are building an open IoT network for the Humber region. We want to get LoRa gateways out there. We want to get people playing with stuff We meet twice a month, first and third Thursday, and we get together and talk tech. There's a certain amount of air quality, there's a certain amount of silly lights, there's a certain amount of folks learning Arduino, there's a certain amount of folks getting PCBs made, which is printed circuit boards. They are the future, apparently. But if you come along, you can sign up and join our get-together community on that URL, and you can visit our webpage and find out what we're up to on that URL. We would love to see you. I want to get people playing with this stuff. It's great fun, terribly useful, and really rather wonderful. I hope that hasn't been too distracting or confusing or whatnot. Any comments or whatnot, send them to robmiles.com. I'm always interested in your comments and feedback, assuming anyone ever actually watches this. And so thank you very much for paying attention. My name's still Rob Miles, and that's it for me.